Hello, hello. It's Mr. Thompson with a video math lesson. We're looking at the surface area of prisms and cylinders. Okay, we're going to start with prisms and talk about those, and then we'll talk about cylinders, and we'll talk about what surface area is and how to find it. Okay, so first let's talk about what a prism is. I'm going to draw a prism here. A prism is a three-dimensional object. Okay, it's in this case we have a rectangular prism, but a prism is basically a three-dimensional object where you take a shape, and in this case it's a rectangle, and you sort of extend it through space. You take that shape and you make it in, you sort of stretch it out almost to make a 3D object. So this one, we've kind of got this rectangle, and if you imagine that rectangle is sort of stretched out, every sort of, if you took a cross section of this block at any point along that arrow, right, you'd get that same rectangle, and the other side of the prism, the other end, is that same rectangle. You can have all kinds of prisms. You can have triangular prisms, which is a triangle sort of extended back through space like that, right? Or even hexagonal prisms, okay, which is a hexagon extended through space, and you can go all kinds of crazy. You can do, whatever different shapes, rhombuses, trapeziums. You can do octagons and whatever you like, and get all kinds of prisms. Now we need to talk about the surface area. Now, what surface area is it's the area of all the surfaces, right? It's the area of each face, sort of the outside shape of each part of the prism. Okay, so any face you see all the way around. So the dotted lines are sort of lines that you can't sort of see if this was a physical object, but we're talking about every single face, the bottom, the back, the top, the sides, and so on. If you add up all that area, that's the surface area of an object. Okay, so how do we calculate that? Well, we're only going to really worry about rectangular prisms, okay, for this lesson. Maybe later I'll do a video on more complex prisms, but we're just going to start with rectangular ones. So with rectangular prisms, it's basically a box, right? That's the easiest way, or a block. That's the easiest way to think about it. We've got three dimensions, okay? Length, height, and width, right? We can use these three dimensions to find the area of this prism. Okay, now the way I like to do this, I'm a pretty visual person, and so the way I like to sort of imagine this is if this is a big cereal box, okay, and or a cardboard box, kind of like a cereal box or whatever, and we're going to make some cuts into this cereal box. Okay, we're going to cut along this dotted red line that I've put in here. So we're going to cut we're not going to cut this face completely out because we didn't cut along the bottom. Just going to cut so that it kind of flops down, okay, and we're going to do the same thing in the back as well, these three cuts, okay, and what we'll get then is these front and back faces will kind of flap down, right? They'll flop down and go flat on the ground. And then we'll also do another cut along this corner back here, this bottom corner. You could cut any sort of edge. You'd have, if I drew the rest of the box on top of here, there would be sort of a box up above this like a tunnel with holes on the end. So if I cut one of the edges of that, like for example along here, right, then the rest of the box kind of folds out, and the whole thing can be laying flat on the floor. So this is called a net. It's a two-dimensional map for how to make this three-dimensional object. If we folded it all back together, then this could become that prism. Now prisms are often solid objects or whatever, but for the purpose of finding the surface area, we can think of it as just all of these shapes, right? And we can kind of take these dimensions and bring them down and mark all of our lines on this thing with these dimensions. So here we have the length, right? These dimensions all along here are length, right? This one as well as all of these ones that are going across that way. We also have this one is also the length. This was the top, right? That top piece, so that length is the same. We have the width, right? The same as this width here is that one, as well as all of these distances across that way. And then all of the short distances along the whole thing are that same as that height, right? They all sort of match, okay? All we have to do is find the area of each of these panels, these rectangles, okay, these 6 rectangles. So this first one is going to be height times length, right? Height times length, L times H, right? And this one up here is also length times height, right? The area. It's just to find, obviously, to find a rectangle, you just multiply the 2 edges, and obviously this is sort of a 3-dimensional rendering here. It doesn't, obviously, if you look at this shape, it's not a rectangle, but you can imagine this 3-dimensional box flattened out, and you're looking at it at an angle or whatever. So they are rectangles. This this rectangle here is this front face, right? Okay, just folded down. We've got other more dimensions here. This one will be length times width, right? This is length, and that's width. And we've got another length times width right here, length times width. And then this one's height times width, and then another height times width. So you see we've got 2 length times height, 2 length times width, and 2 height times width. So there's 3 dimensions. Each one of them gets multiplied by each of the others. So length gets multiplied by the height and times the width and height get multiplied by each other as well. So all we have to do is, to find the surface area, we do 2 length times height plus 2 length times width and 2 height times width. And that's it. That's the surface area. And if you're not a visual person and this didn't work for you, you can just memorize that or whatever. I like to factor out the 2, pull the 2 out, and I can just do length times height plus length times width plus height times width. So each dimension multiplied by each of the others once, and then you add all those up and multiply by 2. Whichever of these sort of suits you better, you can use as you like. Yeah, that's the surface area of a rectangular prism. We're going to look at cylinders now. A surface area of a cylinder, and cylinders are very, very similar. A cylinder is a lot like a prism, but it's circular. Okay, so like just a tube, right? But it could be a solid tube with the top and the bottom. And the surface area, we just want to find the area of all these, the top circle, the bottom circle, and then the round edge, this sort of main tube part, right, around the outside. Okay. Now a cylinder is a lot like a prism in that it is a shape, a circle, extended through space to make this 3-dimensional object. So all along the length of the cylinder is a circular shape. If you kind of cut through it, there would be a circle, right, the cross section. Now we're going to do a similar thing here. I like to imagine this as a paper towel tube, that brown cardboard tube that you get when you're done with a roll of paper towels, right? And what I want to do is make a cut along the length of the tube there, and then kind of fold the whole tube out. If you took those at the cut and folded it and put it flat on the table or something, then it would basically become a rectangle, right? That's what our tube would become. So when we have a cylinder, we can you can sort of imagine the outside of it rolled out as a rectangle. And when we want to find the surface area, we want to find the whole surface area, so we need to include the top and bottom circle faces as well. We need the area of those as well. So let's think about what dimensions we need. All we have now these 3 shapes, 2 circles and 1 rectangle type thing. Okay, the circle, we know there's going to be a radius, right? And that radius, there's the radius. And then there's also this length or what we usually call the height of the cylinder. And you can imagine it would be the height if the cylinder was stood up on its end on that circle and it was standing upright, then that would be the height, right? So when we put those, we can put those dimensions over here. The circles have radius, and that height goes along this edge, and also it's the same obviously as this edge of the rectangle. The question is, what is that edge there, and how do we find it? Well, that edge was it was rolled around the circle. It was the distance around the circle. Okay, and you'll probably know, you may be familiar with the term circumference, right? That's the name of what we call the distance around a circle, circumference. And there's a formula for finding circumference, and it is 2 times pi times the radius equals the circumference. So that's the dimension for this. It's c. You can call it c, or you can just write 2 pi r, right? That's this dimension here. Okay, the sort of length or width or whatever you want to call it of that rectangle. So to find the surface area of a cylinder, all you have to do is take the area of the circle, right? And there's 2 of them. And so area of a circle is, of course, pi r squared. And we multiplied by 2 because there's the top and the bottom. And then we just need to multiply by the area of this rectangle, which is one dimension times the other. So that's 2 pi r, right, times h. And that's it. Okay, that's how you find the surface area of a cylinder. And this is any and all cylinders. Always follow this formula. 2 pi r squared plus 2 pi r h. Really easy. Interestingly, this you can kind of, if you think about this, if you kind of take a step back, this works for pretty much any cylinder or prism if you think about it the right way. You've got the shape that you started with, in this case a circle, and it's extended through space. With other shapes, you might have a rectangle or a triangle or a hexagon or whatever extended through space. And all you have to do is find the area of that shape, multiply that by 2 because there's the top and the bottom, and then you find the perimeter. So in the case of our cylinder, it was the circumference. But if you take the perimeter, right, of that shape and then multiply that by the length or the height of the prism or cylinder, then you get that. You get the area all around, right? And then if you add in the top and bottom, then you've got the whole thing. If that's a little confusing, don't worry about it. You can just sort of follow these formulas. This one for the rectangular prism, and this one for the cylinder. And that's all there is to it. So, great. Good luck.